Hey guys, this is Joyce from Teaching Growth, and this is third trigonometry short that I'm doing. This one's on tangent, and if you've seen my other two videos, the concepts I'm going over is really similar since tangent is just like cosine and sine. It relates the angle and the sides of a triangle. So let's get into it. So first we're going to be looking, of course, at a right triangle like the other two cases. And just as a reminder, a right triangle is simply any triangle with a 90-degree angle. Now, the thing about tangent, and it's different from, say, cosine and sine because it doesn't use hypotenuse. If you remember, cosine related the adjacent to the hypotenuse, and sine related the opposite to the hypotenuse. So tangent will actually relate the opposite and the adjacent, completing the triad, I suppose. So remember our katoa mnemonic. So remember sine, cosine, tangent, and so would be sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. So what this means is that the tangent of an angle, this angle in this case, remember, just like I mentioned in the last videos, the opposite and the adjacent are defined based on which angle you call theta. Which angle are you looking at? So let me give you a quick case. So if instead we were talking about this angle up here, this would actually become the adjacent, and this would become the opposite leg. Of course, the hypotenuse stays the same. It's simply the longest leg, or the quote-unquote diagonal leg. But back to this mnemonic, so tangent would be equal to the ratio between opposite and adjacent. Now, just like the other two equations, this equation can be rearranged and to let you solve for opposite, adjacent, or theta. And so let's do that really quick. If you want to solve for adjacent, we could multiply everything over, and we'd divide by tangent to the other side, so opposite over tangent. And if you were solving for opposite, it would be adjacent times tangent. Now, how do we solve for theta? Just like sine and cosine, tangent also has an inverse function, and we call that tan, or tan inverse generally, or you'll sometimes see it written as arctan. And I'm going to stress this one more time because it's a really easy mistake to make. This tangent to the negative first power does not equal 1 over tangent of theta. As much as you might want to think that, because to the negative power, you'd think it would be, well, it would be 1 over the whatever variable you're putting it over. In this case, it would be the tangent function. But in this case, the negative 1 is the denotation for, say, an inverse function. And you'll probably see this more, even though it's more confusing, but arctangent's also another way to write it. Now, arctangent and or inverse tangent will be the way we use to solve for the theta whenever we're given opposite or adjacent only. And how would we do that? Well, we'd take inverse tangent on either side of the function. If we take inverse on this side and also the other side, obviously taking the inverse of a known function would cancel out, leaving you theta on one side, and with tan negative 1 on the other. Now, this is significant, like I mentioned before, because this lets you solve for angles when you only have two variables. Because if you remember, the equation you learned probably before is Pythagorean's theorem, a squared plus b squared equals c squared. It doesn't give you much room for maneuvering. You must have two variables of the side lengths before you can solve for another one. Meanwhile, this will give you more flexibility. It'll let you have an angle instead. Now that we're done with a quick explanation, I think we should get into a practice problem really quick. And like last time, I think we should do a problem where we solve for an angle, because I think that's slightly more complicated, and it's always good to go over the concept of inverse functions. So we're told that there is a right triangle. I'm going to draw the angle up here this time. Well, it doesn't really matter, but I just think it's good to get a handle on the fact that the sides, or like the names of the sides, depends on which angle you're looking at. So anyway, we have a right triangle, and we are told that the tangent of theta is unknown, but we are told that adjacent is equal to 5 and opposite is equal to 6. And these are units. I don't really know if it's inches or anything, but 5 units, 6 units. And we are told to look for theta. Now, this one kind of throws you off. It makes you think maybe you should use the tangent function, but no, you should be using the inverse tangent function. If you remember SOHCAHTOA, so TOA tells us that tangent of theta equals to the ratio between opposite and adjacent. Now we rearrange this by taking inverse tangent on either side. So inverse tangent on this side and inverse tangent on this side as well, and these tangents will cancel out, leaving you theta on that side, and opposite and, my bad, it would be tangent -1, opposite and adjacent. Remember, this doesn't mean 1 over tangent. This means the inverse of tangent, or arctangent. Now, we can punch this into a calculator. Calculators generally have a function to let you punch in inverse trigonometry functions with like a modifier key, and then you hit the function itself. It's different for every calculator. So I'm going to give you guys some time to punch this in while I do that myself. And that should give you an angle of 50.2 degrees. Now, this is just one example of how you use the tangent function. Obviously, you can flex this equation around all you'd like to solve for different scenarios and use it in conjunction with sine or cosine even. And that'll be all for today. I hope you enjoyed, and be sure to check out my cosine or sine video if you haven't seen it already. And of course, since I am part of Teaching Growth, be sure to check out our YouTube channel or come to our center directly, because we offer one-on-one tutoring, and we don't just tutor in math, we also tutor in whatever subject you need, science, writing. Anyway, that'll be it for today. Thank you.